Hey guys, welcome back to the Geography Academy. Remember, this video is just a small part of a much larger course that's available below if you just follow the links and instructions. Okay, so we're going to go into volcanic hazards now. We can see a couple of things happening now relating to plate tectonics. So we're learning both section plate tectonics and then its reaction to the hazards that are formed. So the first thing we know about tectonic plates is that we get seafloor spreading. So this is when convection currents are going to open up and cause the tectonic plates to move apart. This creates then a magnetic pattern on the oceanic floor, and that's evidence for us that these have moved apart because there's the same pattern occurring in this area, meaning the rock were formed at the same time during the different magnetic polarity in the Earth. So the polarity is kind of changing every once in a while, and this creates then different magnetic sides to the rock as it's being created. So that's seafloor spreading, constructive plate boundary. So seafloor spreading then is being caused by convection currents. These are currents in the atmosphere, the asthenosphere, moving from the mantle. So we have heat from our inner and outer core. This causes magma to rise and then to move across underneath the tectonic plates. And the asthenosphere then, which is the semi-molten area underneath our crust, is going to cause friction with the convection currents. This creates a motion then, and the plates begin to move in that direction. At the same time, we can also see slab pull, so this is when tectonic plates are going back under. We'll come to that though in a little while. So convection currents are the driving force here in a constructive or divergent plate boundary. Both mean the same thing. They begin with the friction that we talked about there at the bottom of the crust and start to move the tectonic plates in the same direction as their motion. Then we see that it begins to open up. So right now we have a rift valley which is opening up in the East African Rift Valley where the African plate is diverging. In that area we're just going to find hollows and more hollowed areas with some water, big bodies of water there. So if you went along to the East African Rift Valley, you will see quite a few lakes, and it's kind of this dip in the landscape then is starting to occur. Next, we see the new ocean basin, so the continuous movement of the tectonic plates apart. This creates then magma rising up and volcanic activity, which creates igneous rock or volcanic rock. Volcanic rock then is more dense than the continental plates. This is starting to form an oceanic plate now. So eventually this opens up and becomes a mid-ocean ridge, and we have a mature ocean tectonic plate that is here. So this is an oceanic plate which is more dense and we can see is more narrow than the continental plate that's being pushed apart, and it creates then new land on that area. Now, by creating volcanic rock, obviously there's volcanic eruptions as the magma comes through every time there is an opening and solidifies and becomes rock. So this, as it solidifies, then creates another process which is known as ridge push. Ridge push is formed because of that new igneous rock that's formed on the surface and creates a new weight. It then pushes down with gravity and is solidifying and becoming more dense. During that process, it creates a push, which is a secondary process on top of the convection currents. In a destructive or a collision plate, no, wait. So these are convergent plate boundaries when the tectonic plates are coming together. If one is being subducted and being destroyed, it's a destructive plate boundary. We can see here that an oceanic and a continental crust are moving towards each other. The oceanic is denser, is made up of igneous rock, as I mentioned in the last one. That igneous rock then is much more denser than the continental plate, so it will subduct underneath, which means it will go back into the mantle. Meanwhile, the continental plate is remaining on top. So during this process, many things are happening. This is called subduction, this process of the oceanic plate going under. The area where they collide here is called the Benioff zone, and this is where we'll see a high amount of seismic activity. So it will create earthquakes. And what we can see going on here as well is that it forms a big trench. So this is where we see some of the deepest parts in the ocean, because the continental plate is being slightly pulled back and the oceanic plate is being pulled down, creating the deepest places in our oceans. It also creates fold mountains because the continental crust is moving this direction and the speed is greater behind it, and now it has stopped here. Therefore, that tension causes tectonic folding here, where the mountain ranges begin to create a much more deeper tectonic plate in this area. So the Andes Mountains, for example, are fold mountains. So in those fold mountains, then we can find a volcano, because the subductive plate then going back into the mantle begins to melt, and hot volatile magma then is going to reach up, and in that fold mounted area it's going to make a magma chamber, and this is eventually going to erupt out of the volcano. So we see volcanically active areas. We also see this happening then along the entire tectonic plate. We're going to see that pattern occurring along there. So because of that, then we would say that it forms a volcanic arc along those mountain ranges. So those volcanic arcs are found in many regions where we find destructive plate boundaries, and we can see multiple volcanoes in a row, like here in the Bromo Mountains in Indonesia. If it happens with two oceanic plates, it can form a volcanic island arc actually as well. So they're found in the Pacific Ocean quite a lot around the Ring of Fire. So we have a lot of convergent plate boundaries. We've got the oceanic and continental. We have the oceanic and oceanic. So here we see those islands appearing, volcanic island arcs. And then we have the continental-continental convergent. So here we see what we call a collision plate boundary. Here there might be some initial subduction, but after a while this plate will disconnect, and what will happen is the mountain ranges will be moving up. So we have tectonic uplift, and we have the formation then of fold mountains, this process known as orogeny as well. Okay, so those are some of the main plate boundaries. In this case, we do find volcanic eruptions in the oceanic and the oceanic and continental, but we do not get volcanoes then in the continental convergent plate boundary, also known as a collision plate boundary. Conservative plate boundaries then are the other types. That's when plates are either moving in the same direction at different speeds, or that they're moving in opposite directions but not moving directly into each other. So if they're moving away from each other. These usually cause quite a lot of seismic activity, but not volcanoes. The tectonic plates usually get stuck, and then when they release with seismic waves. Okay, so a couple of things that might happen around a conservative plate boundary then. It develops fault lines, which increases then the potential for where the earthquakes could happen. So the San Andreas fault line then is a very well-known one. Linear valleys then can occur as well as part of the fault lines and the offset of the two tectonic plates. We also have then earthquake epicenters and the development of different faults throughout those regions. The next one I want to talk to you about is the hot spot. This is also an area where we might find volcanoes, and yeah, it's often found because there's a magma plume. So if we imagine in the middle of a tectonic plate, not around the boundary, but in the middle of the plate, there's just a concentrated area of rising magma that's constantly moving up through the mantle. This magma plume then is going to be able to create a magma chamber in the tectonic plate, and after that, then it's going to cause eruptions, which will solidify, grow, and it will appear as an island. It will appear as a volcanic island and also have eruptions. So those eruptions on island 1 then are formed in the middle of the ocean away from a tectonic plate boundary, which goes against our initial theories on volcanoes only appearing on boundaries. So this one was far away from one. Now, if we imagine there are still convection currents at work here, so this means that this crust is going to have to move on to a new location and move in this direction. So as that moves in that direction, the magma plume stays in the same place. It builds up a new magma chamber, and then it erupts and creates island number 2. And this one is going to be volcanically active as well. And this process just continues as